All right, in this video, we're going to do exponential functions, the applications. So this is real world scenarios here that we're talking about. And this is practice on page 9. So the profits of a company have been decreasing at a rate of 2.6% a year. So that's our rate. If they had a profit of $42,000 in 2015, how much will they have in 2020? So to figure out the time, I'm going to do 2020 minus 2015, and I get 5 years. So 5 is going to be my exponent in my exponential decay because I'm decreasing function. So I'm going to have y is equal to 42,000 multiplied by 1 minus 0.026, and that's going to be raised to the 5th power. Now 1 minus 0.026 is going to be 0.974. And I'm then going to raise that to the 5th power. So I'm showing my calculator here so you understand how to do it. So I'm going to do 0.974 x to the y, because that's for my exponent, 5, and I get 0.88 is what I'm going to round that to. And I have to multiply that by 42,000. So when I multiply that by 42,000, I get 36,816.63. So that's what my y is equal to. And that's how much profit they will make in the year 2020. Moving on to question 2. The value of a collectible toy train has been increasing by 1.2% per year. So that's my rate. So my rate is going to be 1.2 divided by 100, which is going to be 0.012. And so this is the number I'm going to add to 1. So if the train was originally purchased for $4.50, so that's my initial value, how much will it be worth in 20 years? So my function is going to look like this. I'm going to have y is equal to $4.50 multiplied by 1 plus, because I'm increasing, $0.012, and that's going to be raised to the 20th power. Well, 1 plus 0.012 is 1.012, and when I raise that to the 20th power, I'm going to get 1.27. So when I multiply 1.27 times $4.50, I get 5.71. So in 20 years, that toy train is going to be worth $5.71 instead of $4.50. let's look at question 3 here. The number of students at Yellowstone High School has been increasing. So I have exponential growth by 4% each year. There are currently 4,256 students. So that's the initial or original amount. How many students will be there in 8 years? So my rate is going to be 4 divided by 100, which is 0.04. And that's the number I'm going to add to 1. So I'm going to have y is equal to 4,256, because that's my initial amount, multiplied by 1 plus, because I'm increasing, 0.04, my rate, to the 8th power. Now 1.04 to the 8th power is going to be 1.37. And when I multiply 1.37 times 4,256, I get 5,825 students. Because I'm talking about students, I should not have any decimals in my answer. All right, moving on to number 4. The value of a piece of land has been depreciating. Depreciating means decaying by 6% each year. If the land was purchased in 2003 for $62,000, how much was it worth in 2017? So first I'm going to identify my rate, and my rate is going to be 6, because 6%, so 6 divided by 100, so I can get my decimal. So that's going to be 0.06 for my rate. And I need to identify my time. So my time is going to be 2017 minus 2003, which is equal to 15 years. Now I have all the information I need to write out my equation. So I'm going to have y is equal to 62,000, which is the initial amount. That's going to be multiplied by 1.06. I'll write it out. 1 plus 0.06, and that's going to be raised to the 15th power, because that's the amount of time that has passed. All right. When I do 1.06 and I do the x to the y, and I raise it to the 15th power, I get 2.39. Or, yep, 2.40 is what that really rounds to. And 2.4 multiplied by 62,000 is equal to 14. Oh, I made a mistake. That's all right. I can fix it. So that's going to be 14 and 1, and I'm subtracting because I'm depreciating. So I made 2 mistakes. Trying to go too fast here. Sorry, guys. 1 minus 0.06. That makes more sense. And that's equal to 14 years, not 15. And 1.06 raised to the 14th power is 2.26. And I'm subtracting that. So 1 minus 0.06 is 0.94. And 0.94 to the 14th power is 0.42. That makes a lot more sense. The one thing I do like about real-world applications is you can tell right away if it's going to make logical sense or not. So when you multiply that by 62,000, you're going to get 26,072.44 cents. And you would include the decimals because we're talking about a value of money. So you're going to go to your nearest hundredth. So the value of that land in 2017 is going to be 26,072 cents. That's losing a lot of money fast. I would sell that land quickly. All right, sorry about the mistakes on that one, but at least we caught it in the video. And now we're going to move on to question 5. Jasmine started a new job in 2010 with an annual salary of $38,000. If her salary increases, there's my growth, by 5.4% each year, how much did she make in 2019? So my rate is going to be 5.4 divided by 100, which is 0.054. And my time is going to equal 2019 minus 2010, which is equal to 9 years. So because I am appreciating, or the salary is increasing, my equation is going to look like this. Y is equal to A, my 38,000, multiplied by 1 plus, because I'm increasing, and it's going to be 1 plus 0.054, and that's going to be raised to the 9th power. So 1.054 raised to the 9th power is going to be 1.61. And that multiplied by 38,000 is equal to 61,000 and $2.71. So that's her salary in 2019. All right, we're going to move on to the next set of practice problems. It says Vivian opened a bank account and deposited $4,000. So that $4,000 is going to be the initial value. Her balance has been decreasing at a rate of 3.4% annually. How much will she have after 6 years? Okay, so we're going to have Y is equal to 4,000 multiplied by 1 minus, because I'm decreasing in value, 0.034, and that's going to be raised to the 6th power. So 1 minus 0.34 is going to be 0.966 raised to the 6th power. which is 0.813, and I'm going to multiply that by 4,000. When I multiply that by 4,000, I get 3,250 and 29 cents. So that's the value of the account after 6 years. All right. Oh, went too far. Moving on to number 2. A stock investment is increasing by 5% each year. So we have increasing, so we will be adding the 5% each year. So that will be my rate. If the original investment was $2,125, how much will it be worth after 10 years? So my equation is going to be y is equal to 2,125 multiplied by 1 plus, because I'm increasing, 0.05 to the 10th power. When you do 1.05 to the 10th power, you get 1.63. And that's going to be multiplied by 2,125. And you get 3,461.40. So that's the amount of money in the investment after 10 years. All right, we're going to go on to number 3. The value of a motorcycle is depreciating by 2.8% each year. If the bike was purchased for $12,000, how much will it be worth in 12 years? So I'm going to have y is equal to that $12,000 multiplied by 1 minus, because I'm depreciating, so it's decay, 0.028 raised to the 12th power. When I plug that all into my calculator, sorry, I'm running out of time, I get $8,534.47. And that's the value of the motorcycle after 12 years. Okay, last 2 equations I'm going to go over really quickly and hopefully beat the bell. But the value of a house appreciates by 5.1% each year. If the house was purchased for $212,000, how much will it be worth in 4 years? So you're going to have y is equal to $212,000 multiplied by 1 plus, because you're appreciating, 0.051 to the 4th power. And when you plug that all in, you're going to get that equals $258,000, 670.39. And number 5, a small town has a population of 12,000 people. the population has been decreasing at a rate of 3.5% each year. How many people will be in the town in 15 years? So y is equal to 12,000 multiplied by 1 minus, because I'm depreciating, 0.035 to the 15th power. When I plug that all into my calculator, I'm going to get 7,032 people. I don't know why I have a dollar sign. Now all of a sudden people are dollars. All right, so those are the final answers for the rest of your practice problems. Make sure you have them correct. If you're still confused or need help, please ask me in class or come to tutoring.